Okay, let's get started. So first of all, thank you all for joining us today. We're really excited to talk about Cameo DIY detectors, the ability for end users to create their own AI models within minutes and all from within their own browsers is really pretty astounding. It shows what's possible when you leverage the latest AI innovations within an open video processing pipeline. So with that, I'll hand it over to Cameo co-founder and CEO, Carter Maslin.
Hello, everybody. We're super excited to launch do-it-yourself detectors, and we're going to dive right in. But one of the things that everybody's talking about nowadays is ChatGPT and the innovations on these large language models. And I was talking with the security director in San Francisco last week, and we were just remarking, like, the headlines were, AI now passes the bar exam and has not only a passing score, but is acing it better than humans are. And so that same security director was like, I'm reading headlines like that it can pass the bar exam, yet my own team is triaging 10,000 false door alarms every week. Why can't that same level of intelligence be applied to our security systems? And what we're introducing today, the DIY detectors, is kind of a building block that's going to enable that level of intelligence, because you're basically going to be able to expand anything that you see in your video into alerts and search and data that you can access. So we'll dive right in just with demos. So just for background, this is an example of something that you might want to detect. A very specialized vehicle that's a drill rig, the Sandvik D441 or whatever the model is. And it's unique to your environment, but it would be dead simple for you to just click on it and say, tell me if that thing moves after midnight. It's a $200,000 vehicle. We want to know. And what the do-it-yourself detectors enables you to do is, in your browser, click on any object that you see, and then train an AI model automatically based on that example, so that you can subsequently get alerts and data on that. So I'm going to go through some quick examples, but we're just going to dive into actual demos in Cameo after just getting oriented to what the problem is that we're addressing. So this is another example where, if you wanted to know every time this hazardous recycling container is moved, there's no existing AI model in the world that may match your exact regional recycler or regional police officer or whatever specific objects that are unique to your scene. And what this is empowering everybody to do just in the course of using their own video is to click on anything, give it a label, and then be able to get search and alerts and data on that. And for background, the breakthrough from a computer science perspective is that there's a category of work called segmenting, which is just the technical term for knowing exactly where an object is in an image, because you're segmenting out, kind of like a cookie cutter, the perimeter of that object. And usually in AI, you need to train models for the specific examples that you're looking for. And what this is using is a method that, even if it has not seen the object before, it does a great job of segmenting that object, of isolating it in the scene. So this is an example of doing that for a hazardous recycling container, but same kinds of things if you were looking for just a storage item. If you use this kind of container to have high value items that you move from location to location, you can just click on it and say, this is a high value storage item, so that if it ever moves, you can get an alert. Or if you want to track it after it's moved, you'll be able to search for that just by calling it, show me the high value storage container. Same thing, one of the first motivations for do-it-yourself detectors was one of our customers that wanted to know anytime that there were emergency vehicles on premise. And the challenge was that emergency vehicles, whether they're ambulance, police, or fire, often have regional differences. So in this case, the local Liverpool, New York police car is a little bit different than, one that might be in Los Angeles or San Francisco. And so being able to just say, this is our local police, and have that learned is another example that we'll go into. And finally, this is an example just from a residence where detecting a coyote, there may be a lot of models that know dogs and different breeds, but there may not be a Northern California or a Southern California coyote detector, but you've got plenty of them in your own video. So you can just click on the coyote, say, that's the coyote I want to know before I'm walking my dog, and it'll learn that from your own video. And you could see kind of the output of that kind of learning just by scanning that QR code that's on your screen now from your mobile phone, and you'd be able to access this demo example just from your phone. But the whole goal is, no matter what the complexity of the scene, no matter what object that is in the scene, you have an easy way to click on it, detect it, and search and alert and data on it subsequent. So the part that we'll go into next is on what it's specifically doing. So the do-it-yourself detector is first giving you the ability to not have to do any coding or have data scientists do a whole bunch of training data. You're literally just clicking in your browser on the object you want to detect, and that's all that is needed. That one single click then segments the object and then tracks it. So if you take an example of that we just were seeing, even though you only do one click on one object in one frame of the video itself, if it's 15 frames per second, and you've got a 20-second video, you potentially have 300 examples just from that single action. So the exciting thing is that with very little effort, likely less than 30 minutes on your part, and that's probably conservative. You could probably do it in less than 10 minutes, because even labeling maybe 5 different videos will give you enough training data to have a pretty good precision model that could detect that object subsequently. And then once that model's available, it gets automatically deployed to your account. So one of the biggest challenges in AI is actually getting it applied to your video streams without having to worry about how much compute capacity you have either on a camera or on a near edge device or in the cloud. All that goes away. You just know that your video stream will have it applied. So in terms of how it works, this is an illustration of kind of conceptually what's happening. So, the first click on the police car is identifying that's the object that you want to track. And then as the video progresses, we're using a technique that we're calling internally at Cameo segmented object tracking auto extraction, which we just say SOTA for short, because it's looking at where that object's trajectory goes in the video and extracting a whole bunch of samples as it's moving. And one of the ways that you can help with the precision is that Cameo will periodically ask you questions like this. If you've seen this in Google Photos, where you have a face that is the same or different, this is the same kind of concept, but for your own detector. So even though these two vehicles are very similar looking, you as a human know immediately that the left is the police car and the right is not. And that's going to be just modest fine tuning that will just make the model better and better over time. And that same feedback loop applies to activities. So you may care about a police vehicle that stops and enters your parking lot, but you don't care if the police vehicle is just passing on the street. So if you have an activity like passing, you can say, is this trajectory passing or not? And that helps you have an alert that's specific to saying, I want to know when any emergency vehicle is on our premises, as opposed to passing by. But all of this is background activity on background introduction on what do-it-yourself detectors are. It's more fun to just actually use it. So I'm just going to go into some examples on our own demo video. So I've saved some things 3 weeks ago to now that are saved. So I'm just going to say 3 weeks ago to now saved. And this will pull up some events that I marked that I wanted to illustrate. So this first one that we were doing with the police vehicle, I'll go to the cover image of this event, and then we'll open up the annotation labeler for that event. So this was the event that we want to label, and this is the scene that we're labeling. So the thing that you can notice is as I pass my mouse over this person, it highlights the person. Or if I highlight it over the general sidewalk, it'll know the sidewalk. We want to label the police car. So I just put the mouse over the police car, click it once, and then I'm just going to say, this is Liverpool Police. And now that that's labeled, the subsequent images in the video will be extracting that object for the training data. And just as background on the reason that we're so excited about this is that when we were mentioning this concept of zero-shot learning, no one has trained a model on that police vehicle or not even on this telephone pole or this bush. But you can see that just hovering over the bush, it does a really fantastic job of segmenting that object. And so the ability to so quickly identify vehicles like this uniquely in the scene, again, intuitive for humans, but this is a breakthrough in computer science because it's doing it on things that it's never seen before. I'll do a couple other examples like from 4 weeks ago. So let me just change this to 4 weeks ago. I know that we had the same trash truck example that I was going to show before. So let's say that we want to know whenever Recology picks up our recycling bin. I know that this is a common problem in commercial settings where people dump their trash in your bins. So we're going to do the same thing on this and bring up the segmenter. And the thing is you'll see that it detects the car, and notice that the detection even excludes the foreground pole. So this pole is not included, but then this car cutout is included. If I come over here to the trash truck, it does a great job of excluding the sign in the foreground even. And so I can do the same thing we did before where I'll just say this is the Recology truck. And by default, if you label something, the other moving vehicles in the scene are assumed to be not a Recology truck. But if you had multiple Recology trucks, you can explicitly say this truck right here is not a Recology truck. So if you want to give it a little boost when there's ambiguity, you can do that. But the basics you can just do just in the asserting in the positive. And I want to show one other example that's showing the level of granularity on this. If I try to label the exact bin, so let me go over to this where he's taking these two trash cans and there's a recycle over there. I know this is kind of a mundane example, but it's good just to illustrate what's happening behind the scenes. So we'll open up the same segmenter, and you can see I can hover over this trash can, click it, and I'll do the same thing by saying it's a Recology trash can. And because this is another one that's also moving, I'm going to click that, and then I'm just going to say that's also a trash can. So now these two objects, as he moves them in different angles and stuff, provide great training data. Just from this one sample, we'll have roughly 600 training images from the movement of those two cans. And that's distinct from this. You can see this little blue recycling one. I'm going to click on that, and I'll just say this is a Recology recycle bin. And you can see the precision here. That's another one of the trash cans. So I'll just say that's a Recology trash can. So you can see how quick it is to be able to just highlight any object in the scene and give it a quick label. So there's a whole bunch more examples that we could go into, but this is the thing that is exciting. It's running a model that is over 2.5 gigabytes in size. And yet you're applying it to an image in your browser with just a regular browser URL. There's no special software you need to install on your client to get this done. So the core advantages are that you take the same search box that Cameo is anchored on for the entire video processing pipeline. Searches that tell you things like, tell me unauthorized people in our building, or tell me when there was a FedEx delivery, things like that. The search box vocabulary can expand to anything that you see in your video. So the core benefits of this is that there's no bound to what you can get search and alerts and data on. So that enables you to reduce false positives in your GSOC event streaming. So if you want to say something like, in evening hours, I want to see anybody that is on the property or in the garage that's not one of our security guards. Well, before, you're defining what one of your security guards was a bit difficult, because you may have a particular uniform that's unique to your guard service that's different from another guard service. Now you can just click and train on that uniform and then decide how aggressive you want to be in filtering out. When only a guard is in the scene, you may not be as interested in triaging that. The second is it accelerates investigations. So if you have a particular object like that high value storage that you need to quickly see where it went and who moved it, now instead of having to define some set of criteria beforehand on what object similarity might be, you can literally have an AI model on that specific object. So being able to leverage the power of all these AI advances to be able to go find something is a big improvement. And then the last part is just removing the limitations on fixed AI models. But part of the fascination of ChatGPT since November is that it's so general. It has so much information that it's even creative about what it can do on the basis of that. And in this case, if you look at the security industry, the typical cycle has been, hey, here's a list of features we have. And then end users evaluate that and say, you're missing this. Can you add this? And what this is enabling, this do-it-yourself detector, is to have really the end users create the features that they want. So it's unbounded. It's the analogy that comes to mind for me is that, in the first version of the web, there were a whole bunch of published information and documents that you could search. But the Web 2.0 moniker was about users that were contributing content, with Reddit and GitHub and forums like review sites and things that all made a lot more of the information that's now training these kind of large language models, because humans were creating the content that was indexed on the web. It wasn't just published official sources, but it was people's everyday interactions. That's the same thing that can come to the security industry, in the sense that now, whether you're a specialized manufacturer or a special mining facility or an oil rig with a lot of specialized equipment, all of the things that you see as a human are now accessible as searchable and alertable objects. So it really removes some of the restrictions that were there. And I think that ushers in this kind of next wave and is truly like a watershed moment for us as a security industry technology provider, because you're going from asking vendors for features to instead looking at the strengths of the AI ecosystem, where these advances like we're showing today didn't come from the security industry. They came from big tech companies that are investing billions in AI research. And that shifts everybody's launch from, instead of starting at zero with a new product, you're really creating a flywheel that has compounding benefits, so that every time users labeling something, it's getting that much better for all the other users in your organization. So that really is going to accelerate our progress. And in this case, where you've got now the ability to generalize with this zero-shot learning on the scene and label anything in a search box that can accommodate anything without a lot of complicated dialogues or settings, but just natural language, it really feels like this, there was a time before this and a time after this, kind of like when the iPhone launched and you had a sleek new Motorola Razr. There was just no going back to a Motorola Razr after you'd experienced an iPhone, because the experience was so much better. And I think that's where this is a building block that's going to enable that for the security industry. So like I mentioned, one of the earliest users that motivated these do-it-yourself detectors had specific motivations around eliminating dangers in residential areas like pools, where kids were at risk if there were floats on top of the pool that could create a drowning risk for a little kid. Or if there were beer coolers, you might have another kind of risk that you want to avoid. And so when people were asking about kind of the correlation between artificial intelligence and making security systems easier and artificial intelligence that you see passing the bar exam and medical exams and stuff, we really see a security 2.0 on the horizon. It may not be immediate, but it's definitely attainable. And so if you look at how you as a person running security will eventually be able to ask for things, this is an example of something that I think we would be able to say. So if you're the head of security for a multifamily residential property company and you want to just say this, you could type it like you would ChatGPT, like alert me whenever our on-premise, alert our on-premise guards whenever there's any kind of safety concern in our pools. And if you go to ChatGPT and say, what is a safety concern around a pool? They'll tell you, it's kids running or diving in shallow end or horseplay or small kids unaccompanied. All of that is known by AI and can be translated into these searchable video and alerts. So the first sentence has already got a ton of power in just being able to say that. But then you can augment that with saying, we've seen problems whenever people bring beer coolers or use floats in the pool. Unaccompanied kids are a big risk. Hey, and when the pool is crowded, send a lifeguard. So having that actionable insight on video to actually dispatch a lifeguard when there's a lot of people in the pool is also within the realm of achieving it now. And then at night, make sure the pool lights are on. This is the stuff that we had added with luminance detection to be able to know whether a pool light is on and off. And make sure the gate's closed. So if nobody should be in the pool area between 11 p.m. and 6 a.m., again, time-based constraints on the query, you can just say 11 to 6 as a schedule. And if there are no guards on premise, make sure the GSOC dispatches one. So that's telling you what events should be dispatched to your Global Security Operations Center. And if our uniformed guard shows up to clear the scene after there's been a problem, it's safe to ignore it until that guard has cleared everybody from the scene. So the whole idea of knowing that there's a time basis where there were, 5 people around the pool, the guard came in, cleared them out. You don't have to be worried about it until the guard has finished that clearing out, which may take 15 minutes. And that saves your staff a lot of time, triaging events that are just already known as not being risk because there's somebody on premise to take it. So we're super excited because this is like I say, a foundational element for a big shift that really should be able to have our systems tell us what warrants our attention and a whole new level of capabilities. And if you guys want to find out more, contact Hunter. He's our head of sales at hunter@cameo.com. And if you have any follow-up or open questions, we're happy to take those now, but also just contact us at info@cameo.com. The other thing is you can go to cameo.com/DIY for do-it-yourself to learn more. So this webpage has a landing site and you can join the wait list. We're doing a slow rollout of this and we'll get to you as soon as we possibly can. But I'll just pause here to see if there's any questions right now interactively. And if not, we'll wrap it up and follow up.